Alright, and welcome to 1.1 Horizontal and Vertical Translations. So just as a reminder, the word translation is a shift. And there's two types of shifts. There's the left and right, and there's the up and down. So we'll see how that works. So if we start with a graph, f of x is equal to x squared, and sometimes we might say y is equal to x squared, and other times we might say f of x is equal to x squared. We're going to be playing around with this function notation a little bit today. So let's fill in some dots. So 0, 0, 1, 1, and you'll sort of see this step pattern. You're probably familiar with it from last year. If we go over 1 and then up 1, and now if we go over 1 and up 3, or I'm sorry, over, and then we want 2 and 4, so that's over 1 and up 3. And if we did 3, it would be 3 and 9, so it would be over 1 and up 5. But of course we don't have room for that, so you see the 1, 3, 5, you see that sort of pattern there. So we're going to go left 1, up 1, left 1, up 3, and we don't have room for too much more. I'll erase a bit of my mess here, and we'll try to draw in a nice sketch here of a curve. There we go. And I'll draw the other piece on there too. Okay, so this is sometimes called a parent function, or the original function. So if y is equal to x squared is equal to our parent function, then what happens when I add this minus 2 part out to it? Now, last year, probably most of you will have taken parabolas and done some type of a formula where you had, I think it was x minus p all squared plus q. Often you'll have the p and the q. It depends a little bit on which teacher or which textbook they were using, which resource. We're really going to do something very similar to that, except instead of p and q, we're going to be using the letters h and k. So looking at this one here, this one would have a k value of -2. And let's see what happens when you have a k value of -2. And you'll probably even remember this from our last lesson. If I plug a 0 in here for x, I'm going to get a -2. Nope. I'm going to get a -2. If I plug in a 1 for x, 1 squared minus 2 is equal to -1. So you see you get that over 1, up 1, and then over 1 another, up 1, 2, 3. We're going to get this same pattern like this, and our sketch is going to look very similar. See if I can make this line work. Like that. It's going to be very, very similar to what we just had, right? What's the difference between these two? Well, it seems to me that what happened was this got dropped down to. So if I grab this, maybe I'm grabbing the wrong thing here. There, if I grab this, I could just bring this down 2, and that's essentially what happened here, is that when I added a k value of -2, the graph went down 2. So that's the first translation that we're learning, is that this k value makes the function go vertically up or down. It shifts it up or shifts it down. Now this one here in our function, now we've changed the letter, we've called it h. In this one, inside here we've got a -1. We're going to have h is going to be equal to -1. Maybe it's a bit confusing. I'm going to change this function. We'll call it I don't know, we'll call it I, function I, just because I'm using the same letter h here. So h is equal to -1. So what's going to happen to our function? If I plug a 0 in for x, then inside the parentheses I get -1, and -1 squared is 1. So a 0 for x gets a 1. If I plug in a 1 for x, 1 minus 1 is 0, and that squared is 0. If I plug in a 2, 2 minus 1 is 1, 1 squared. So you'll see what happens here. We get the beginning of that parabola again, where our vertex You remember our vertex is going to be at h comma k, or p comma q you called it last time. So here is 1, 1, 2, 3, 1, and then 1, 2, 3. Get that same pattern. Here is, I'm going to pick a new color here. Maybe I'll just go with black. Here's our new parabola. And so how did that shift from our original one? See if I can get them both on there at the same time. Well, in this one here just shifted to the right 2, didn't it? Or actually shifted over to the right 1. So in our case here, it's interesting that when h is equal to, I'll talk about what h is. H is actually plus 1, because when you look inside this a is equal to x minus h all squared, it's x minus h. So if it's a minus 1, then h is equal to positive 1, and it shifts right 1. So whatever the h value is, that's how far it goes to the right. Okay, so my k shifts it vertically, and my h value moves it left and right. So why does it go, if it's x minus 1, why doesn't it go to the left? Why does it move to the right? That might be a little bit opposite of what you might think. So the way that I sort of understand this is that I have to kind of compensate for this minus 1. In order to get the same y value, I have to make my x 1 larger to compensate for the fact that it's going to be 1's going to be subtracted from it. So that's why my entire shape here gets shifted over to the right one, because I have to put, if this was my original y is equal to x squared, I have to now compensate for the fact that x is going to be subtracted by 1. So all the x values, in order to get the same y value, have to be 1 greater to begin with. Okay, what do we have underneath here? So now we have two combinations. So let me just remind ourselves, if we have a pattern of x minus h all squared plus k here, what are my two values? Well, the first one is easy to tell, is that k is equal to 1. So that's going to be up 1. And now my h is going to be equal to, so because this is minus h, it's the opposite of whatever we see here. If this is a plus 2, h is going to be a minus 2. Okay, so let's take a guess. If when our h value was plus 1, that's when we went right. So now if our h value is going to be equal to minus 2, you guessed it, we're going to go left 2. Okay? Another way to think of it is that the vertex is going to be at negative 2 comma 1. So if I go negative 2 comma 1, there's my vertex, and then I fill in the rest of my dots over 1 and up 3, 1, 2, 3, just past the edge of my graph. 1 and 1, over 1 and up 1, 2, 3. And so here is what my new graph is going to look like. Didn't do quite so well, kind of missed that dot over there. So this is what m of x is going to look like. Okay, so looking at this one here, the following graph represents f of x. So this is f of x. It's already given as a function. Now, the notes tell us that this happens to be this function here, but we actually don't need to know this. So I can sort of cover this up and say, don't worry about this. Like, this is sort of extra info, in case you're wondering. Okay, we really don't need it to solve the question. So the question here says, now, if this is our original f of x, what happens when we say, let's graph f of x plus 3. So what is this more similar to? And you'll notice that the two different ways we can add numbers. We can either add numbers inside of the function or outside of the function. Here what we're doing is I'm thinking, I'm going to graph f of x, except for wherever I see an x, instead of the regular x, I'm going to use an x plus 3. Okay, so it's quite similar to what we're doing over here, where instead of using an x, we used an x plus 2, right? So if our parent function was x squared, and having an h value means that we replaced x with x minus h. So this, when I'm looking at this f of x plus 3 because it's inside of that function. I'm replacing x with x plus 3. I'm mentally right away saying to myself, okay, that means my h value is going to be equal to the opposite of plus 3. It's going to be equal to minus 3. And right away I'm thinking that's going to mean I'm going to go left 3. So on my graph, in that nice gray dashed area, that's my original f of x, right? So if I compare, here's my original f of x, okay, and now on the graph, it's just there for reference purposes. So what I can do is I can take the important points and say, okay, I'm going to move them left 3, 1, 2, 3. So I'll go there. And I think it's supposed to be a nice straight line. And then this one's supposed to be a nice straight line there as well. Okay, so what about this one? Now I'm not replacing x with x plus 2, I'm adding 2 afterwards. So this is the same thing as having a k value of plus 2. I should change that there and say, there we go. Make that k value equal to plus 2. So that means I'm going to translate it. I'm going to shift it up 2. So if this was my vertex or that center point there, now this is what it looks like. Okay, so now we're doing two things at once. I'm going to have an h value. Remember, it's the opposite of this, so h value is equal to plus 1, and my k value is equal to negative 2. So the two things I want to do is I want to go down 2 because of my k value. I want to go right 1 because of my h value. So I will start from here. I'm going to go right 1 and down 2. So that's where I'm going to start, and then I'll draw our shape. Okay. So when I have a transformation like this, the effect on the graph is this k value is what we call a vertical translation. So if k is positive, so say if k is greater than 0, just another way of saying that's positive, shift k units up. If k is less than 0, shift units down. Now I just want to be careful of the way I phrase this. I don't want to say shift k units down because you might be thinking, hey, it's a negative, so how do I go negative units down? So here, just to be precise, I'll say shift the absolute value of k units down. So for example, if we had y is equal to f of x minus 2, then we'd say, yeah, k is less than 2. I'm going to shift the absolute value of negative 2 is just merely equal to 2. So that's what I mean by putting that absolute value symbol on there. Okay, I'll just erase that little bit of stuff so I have room for my other one. Okay, so now looking at the h value, the h is responsible for a horizontal translation. And remember, the word for translation means the same thing as a shift. Okay, so if h is greater than 0, then we shift h units right. And if h is less than 0, we will shift, and again I'll just say the absolute value of h units left. Okay, so if we had if y is equal to f of x plus 2, so remember how we do it. We go and we say, okay, if this is plus 2, then that means that h is always equal to the opposite of that, so h would be equal to minus 2, and in this case we'd be shifting 2 units to the left. Okay, this is this is my preferred way of writing it, and this is what we've been dealing with as well. But you'll see that mathematically this is identical, right? So what happened here is we took this k value, and if we subtract k from both sides, okay, I'm subtracting k from both sides, then this turns into this form of the same equation. And sometimes your textbook will have it in this form, but I think this is the #1 way that we get it presented to us. So we still use the same thing. We still think what the k value is. So even if there's that minus sign, we would say if the k, if we had, say, y plus 2 is equal to f of x, and then in this case k would be equal to -2, and you could see that would be the same thing as saying y is equal to f of x minus 2, right? So k would be equal to -2 regardless of how you look at it. If it's written on the right hand side, k is equal to whatever that is. If it's written on the left hand side next to y, it's the opposite of that. Okay, so if you don't want to have to remember all that, you can just always shift it into this form and then you're good to go. Okay, let's compare these two graphs here. If g of x is equal to f of x minus 1 plus 2, sketch the original graph, f of x. Okay, so this is the original, and then this is the image. This is the new one. Okay, and it's like we're given the answer, but we have to kind of figure out the question in a way, all right? So if this is the original, and if g of x is equal to this f of x minus 1 plus 2, if we would have been given the original and to make g of x, what had to been done? This minus 1 means that if I just draw on here, h is equal to 1, k is equal to 2. If h is equal to 1, that means my original f of x, I had to make it go left 1, and I had to go up 2. So if I knew what the original function was, then the original function after I went left up and up 2 would have given me g of x. Okay, so how could I go the other way now? So if I'm given g of x and I have to figure out what f of x was, if I have to go from my image back to my original, I have to undo those things. So I'm going to be going right 1, down 2. So here I can take each of these points and I will go right 1 and down 2. Okay, so nicely on here we have the points, the original points made here, so I'm going to go right 1, down 2. I'll take this one and I'll go right 1, down 2. And I'll join that. I'll take this point here, I'll go right 1, down 2, and we'll join that. See if I can kind of use a straight edge here. Hey, that kind of worked. And it looks to me, it's a little bit hard to read, but I think it ends here, so I go right 1, down 2, and it goes here. So just to be careful, I do have a closed circle there, and I have a closed circle there, so when I make my graph, I want to make it very clear that it's closed. It's a closed circle there and there. I'll just inspect it. Looks pretty similar. Yep, I do think I did a good job on that. You'll notice that the scale, it looks smaller because the scale's made different. Here's 0 down to -3. This is 0 down to -4, so it looks like the one on the right, the graph actually got a little bit shrunk, so that's why it looks smaller. Okay, so I don't really have a note here. Maybe you can summarize what we did about undoing and put your own note in there. Here's another example, example number 3. Determine the equation of the translated function in the form y is equal to f of x minus h plus k. Alright, so here is my original. So this is my parent. And this is my image. This is the one that was made after it. So how is this changed? It seems to me, in terms of left and right, it went left 4, So my h value is going to be equal to 4, and it seems to me that it went down 5. So my k value, oh, I made a mistake. Left 4, so my h value is equal to minus 4. My k went down, so it'll be minus 5. So when I write this, you'll remember that I wanted to do it in this form here. Y is equal to f of x minus h plus k, and now when I put in my numbers here, I'm not actually talking about y, I'm talking about g of x, just to make sure I'm answering the question exactly. G of x is going to be equal to f of, and now x minus negative 4 is going to be equal to plus 4, and then there my k is minus 5. So just putting a box around the answer. There we go. Looking at my other question here. Okay, so it seems to me if I start here, in terms of left and right, I'm starting at minus 5 and I'm going to minus 1. So I think it goes right 5. So that means that my h value is going to be equal to 5. It goes down, how much? 2 plus 7 goes down 9. So my k value will be equal to negative 9. So in this one I will write g of x is equal to f of x minus h, so x minus 5, and then minus 9, because if my h value is positive 5, here I put the opposite of that, I put minus 5, so that it will shift 5 to the right and 9 down. Your turn. So I will hit pause, and I want you to make a statement here where in your answer it's going to look something like g of x is equal to f of x, and then I want you to put something here, and then put either a plus or minus over there. And then for our last one, I think you will write something like a prime is equal to, in this case, it's not written as a function, so maybe we'll write a of x either plus or minus something, and then plus or minus something there as well. So we'll turn it into a function notation. I'll call this a of x. How's that? Okay, I'll hit pause and I'll see if you guys can complete those. Okay, let's see how you did. Looking at the first one, it seems to me that we move right 4. So my h value is going to be equal to 4. And it looks to me like we move up 6. So my k value is going to be equal to 6. So then I can say that g of x, we're going up over here, g of x is going to be f of x minus 4 plus 6. Right? So if my h is 4, I write in here the opposite of 4. For the second one, it seems to me that we're moving left 8. So my h value is going to be equal to negative 8. And we're moving up 3. So my k value is equal to 3. So if h is negative 8, here I'm going to be writing plus 8. And I'll write plus 3. Okay, so these are the questions to do for your homework. This is in our class textbook. And I'll see you in class.